Good day, students. Welcome to mathgodserve.com. In this clip, we're going to be going over problem 6 of the 2003 AP Calculus free response questions based on piecewise defined functions. Alright, let's take a look at the problem. 6, it reads, let f be the function defined by f of x equals root x plus 1 between 0 and 3 and 5 minus x from 3 to 5. The A part. Is f continuous at x equals 3? Explain why or why not. Okay, so before we determine the continuity or lack thereof of this function at x equals 3, let's go over a rule. Okay, so what's the rule for determining if a function is continuous or not at a point? So f is continuous at a specific x value, let's say a, if the following conditions are met. If the limit as x approaches a from the left-hand limit, is equal to the value of the function at that specific x value where we are trying to ascertain continuity, and that is equal to the limit as x approaches a from the right of the function. Okay, so a shorthand way of writing this is a function is continuous at a point if the left-hand limit to that point is equal to the value of the function at that point and is equal to the right-hand limit to that point. Okay? Alright, so in this scenario here we have two functions, okay? Function 1 from 0 to 3 and then function 2. So in order to help us have a visual as to what's going on, I always like to use number lines when dealing with piecewise defined functions, okay, so we don't get anything mixed up. So let's draw our number line. So we're going from 0, 1, 2, 3, 4, 5. Okay. Alright, so we have two functions here. One goes from 0 to 3, so from 0 all the way to 3 included we have the radical function there. Okay, so from 0 to 3 we have square root of x plus 1, and then from 3 to 5 excluding 3 we have another function, namely the linear function. Okay, let's go ahead and sketch that. So we have the linear function from 3 to 5, and then 5 is included. 5 minus x. Okay, so we have the following situation. So if you're approaching, we're looking for continuity at x equals 3, right? So this is where our focus is on. So if you're approaching 3 from the left side, that is known as the left-hand limit. Okay? If you're approaching 3 from the right side, that's known as the right-hand limit. If you're evaluating the function at x equals 3, that's just basically the value of the function. Now, in order for there to be continuity, all these three must be equal to exactly the same thing. So that's what this question is asking. Is the left-hand limit equal to the value of the function, and is it equal to the right-hand limit? Okay, so let's see if all of them line up. Let's start with the left-hand limit. Alright, so which function comes to play when you're to the left of 3? It's this function right here. Okay, so write down the following expression. Limit as x approaches 3 from the left of the function. Okay, now since the function in play to the left of 3 is root x plus 1, we're going to rewrite this as limit as x approaches 3 from the left of root x plus 1. Okay, now we can evaluate this limit. We can evaluate this just by substitution. We don't have anything funny happening here. So square root of 3 from the left plus 1. Now, since we're not dividing by 0 or anything like that, we can just make 3 approaching, I mean, approaching 3 from the left is just the same thing as 3, okay? So this is just going to be the square root of 3 plus 1. Nothing funny happening here, so we have the square root of 4, which is equal to 2. So that's your left-hand limit. All right, what is the value of the function at x equals 3? So that's basically f of 3. Okay, so for f of 3, which of these functions are we going to be using? You notice for the function to the right, we have an open circle, and a function to the left is closed. So we're going to be evaluating the function to the left, root x plus 1, at x equals 3, because that's where that interval includes the boundary point x equals 3. Okay, so you simply plug in 3 there, so you have the square root of 3 plus 1, which is the square root of 4, and is equal to 2. Looking good. All right, so final part is the right-hand limit. If the right-hand limit is equal to these value 2, then the function is continuous, or else it's discontinuous. Okay. All right, so we have the limit as x approaches 3 from the right of the function. So from the right, we're looking at the limit as x approaches 3 of which function is active from the right. Let's go back to our graph. So it's 5 minus x, right? So that's what we're going to be using for the right-hand limit, 5 minus x. And then you plug in 3, so you're going to have 5 minus 3, and your final answer is 2. All right, so what does this mean? It means that the limit exists because all these 3 values are equal, okay? So if you take a look at the problem, we're asked to answer, is the function continuous or not? And then we are to state an explanation. Why is it continuous or discontinuous? Okay, so let's go ahead and write it. Is the function continuous? Yes, the function f is continuous at x equals 3. Why? So we'll just state our reasoning, okay? Just explain what's going on here. The function f is continuous at x equals 3 because the left-hand limit as x approaches 3 from the left of the function is equal to the value of the function, f of 3, and is equal to the right-hand limit, the limit as x approaches 3 from the right of the function. Okay, so just by writing down the statement, that's a sufficient explanation. All right, so stating yes, the function is continuous, that will earn you 1 point, and then the explanation as to why you answered the way you did will earn you another point, for a total of 2 points for question 6a. All right, let's take a look at question 6b. It says find the average value of f of x on the closed interval 0 less than or equal to x less than or equal to 5. Okay, so before we start, let's take a look at the formula for the average value. Okay, so f average on an interval AB is given by 1 over b minus a, okay, times the integral from a to b of the function. Okay, all you're just looking for is the height of the region. If you convert the region into a rectangle and you divide the area by the width, you're left with the height. Okay, so that's what f average basically is. Now, something I'd like you to keep track of, something to note, is that piecewise defined functions must be integrated in pieces. Okay? Just like the name indicates, piecewise defined functions. So don't try using one function to integrate a piecewise defined function over an interval. Since we're going from 0 to 5, let's go back to the question. We have two functions here, so you have to take into consideration where each function is active, and then you integrate the respective functions over the intervals where they are active. Okay, don't just blindly use one function to find what the integral is, because that will be incorrect. Okay, so what I'm saying in essence is we're going to be having a composite integral made up of two pieces. Okay, so let's set that up. We have the average value of f on the interval 0 to 5 is given by 1 over b minus a. In this problem, b is 5 and a is 0. Okay? 1 over b minus a. So a is 0 here. So 1 over b minus a times the integral from 0 to 5 of f of x dx. Okay? Alright, so we have two functions that we're integrating. Okay? So we have 1 over 5. What we're going to be doing is we're going to be splitting up our integral into two pieces. So we have the first piece goes from 0 to 3. Okay, So for the first piece, we're going to be finding the area of the function from 0 to 3, f of x dx, plus the integral from 3 to 5. Remember what I indicated that we keep track of earlier. If we're integrating a piecewise defined function, you have to integrate in pieces. Now, how do I know to stop at 3? Well, if you take a look at your intervals in a given problem, notice how it's broken up. For function 1, you're going from 0 to 3, the radical function. For function 2, from 3 to 5, you're looking at the linear function 5 minus x. Okay, so that's why we broke it. We basically use this breaking point right here to determine our limits of integration, where the first one stops and where the second one starts. Alright? Okay, so now let's go ahead and substitute the values of these functions in there. So we're going to have 1 over 5 times the integral from 0 to 3 is the radical function, root x plus 1, and the integral from 3 to 5 on that interval is our linear function 5 minus x. Okay? Alright, so let's go ahead and start integrating. But this one, we can use u substitution, but I'm going to use a shortcut to make it faster. So I'm going to write it like this: 1/5 times times the integral from 0 to 3 using the properties of exponents. I can rewrite that as x plus 1 raised to the 1/2. That's the same thing as the square root. The x plus the integral from 3 to 5 of 5 minus x dx. Okay, the linear one is going to be easy to integrate. The one on the left, not so much. Alright, so let's see what we have here. Now, on the left side, I'm going to be using, so we have a linear function as the input right here. You can use the following shortcut. Okay, this is basically condensed u substitution. So let's say you're integrating a function like this. So you're integrating mx plus b to the n power dx. The integral is simply going to be mx plus b to the n plus 1 over n plus 1 divided by the coefficient of m. or times 1 over m. Same thing, okay? So this is because your inner function is a linear function, so when you apply the u substitution, you end up multiplying your result by the reciprocal of the coefficient of x, or just divide your answer by the coefficient of x. Okay, so if I apply that idea here, we have 1 over 5 times, we have x plus 1 using the power rule to the 1/2 plus 1. Okay, so that's the power rule. 1/2 plus 1 divided by 1/2 plus 1. And you're going to divide this entire result by the coefficient of x, which is 1. Or you just multiply it by 1 over the coefficient of x, which is just 1. In this case, it doesn't make any difference. Okay? Now we're going to evaluate this antiderivative from 0 to 3. Okay, so that's the first one. Plus. Second one is easy to integrate. Antiderivative of 5 is 5x. Antiderivative of, let's see, antiderivative of x, so it's going to be x to the first power, right? So 1 plus 1 is 2 over 1 plus 1, 2. And this will be evaluated from the other part of the interval, 3 to 5. Okay? So that's what we have to deal with. So let's go ahead and start simplifying. All we're going to be doing from here on out is mainly arithmetic simplification. Okay, but we're still doing some calculus, so we can't stop yet. So let's proceed. We're going to have 1 over 5. Let's see, I want to try make sure I don't run out of space. 1 over 5 times. Now, let's simplify this, okay? So we have x plus 1. 1/2 plus 1 is 1/2 plus 2 over 2, which is 3 over 2, divided by the same thing, 3 over 2, multiplying by 1 over 1. Doesn't change anything, so we're evaluating this from 0 to 3. Okay, plus, let me not evaluate this one yet. Let me just hold off for a second. So leave this one alone. I'm going to start simplifying it in the next line. X squared minus over 2 from 3 to 5. Okay, now let's see what we have. Now I'm going to start using it. The second part of FTC part 1, you plug in the lower limit minus, plug in the upper limit minus you plug in the lower limit. So you're going to have 1 over 5 times, if you plug in 3, you have 3 plus 1 raised to the 3/2 power over 3 over 2. Let me change how this looks like, because I'm going to be using the bracket parenthesis. So I have 1/5. Then we have this scenario right here. Squiggly bracket. And then bracket. That is what you get when you plug in 3 minus what you get when you plug in 0. 0 plus 1 to the 3 over 2 divided by 3 over 2. Okay, and then you close that. And then plus, on the right side, you plug in the upper limit first, following FTC part 1. If you plug in the upper limit, you end up with what? 5 times 5 minus 5 squared over 2. Alright, and then you have this entire thing minus, so we have a bracket there. this entire thing minus, and then you plug in the lower limit, 5 times 3 minus 3 squared over 2. That's what you get when you plug in the lower limit of integration. Alright, and then you put in the squiggly bracket. Alright, now guess what? If you stop right here, because everything that's left is just arithmetic manipulations. If you stop right here, okay, you get full credit. Okay, so just if you stop right here, you get full credit because everything that's left is just arithmetic. But if you want to proceed, you have to make sure that your answer must be correct, or else you're not going to get, you're going to lose the point for your inaccurate arithmetic computation. So on the grading scale, from here on out, you're going to get 1 point. Okay? So keep that in mind. I want you to notice how much work I'm going to be doing just to get 1 point. And if you had stopped right here, you get full credit. Okay? So the following is not advisable, but I just want to satisfy your curiosity if you want to see what the final answer looks like. Okay? But on the AP exam, you definitely want to stop after you've executed all your calculus steps when you're applying FTC Part 1. Alright, so let's go ahead and just have some fun with some arithmetic manipulations here. So let's see. We have 3 over 2 down there, so we just multiply the top by the reciprocal of this. So it's going to be 2/3 times 4 raised to the 3/2 power. Same story here, you're going to have 2/3 times 1 raised to the 3/2 power. Okay? So just keep track of how much work we're going to be doing and how much time is consumed doing this. And then you see why it's not advisable. Okay, and then let's go on. 5 times 5 is 25 minus 25 over 2 minus parenthesis 5 times 3, 15 minus 3 squared is 9 over 2. Okay, now close up squiggly bracket. This is where some students might actually get stuck and get lost and lose their calculus points over arithmetic error. They'll say, okay, you know what, like I have 2/3 here. What on earth is this? What is 4 to the 3/2 power? Okay? It's not that complicated, but you could easily get flustered in the exam. To do this, all you simply have to do is you take the square root of 4 and you raise the answer to the 3rd power. Okay? And then you have 2/3. Same thing here. You take the square root of 1 and then you raise it to the 3rd power. Alright. So that's that for that part. Plus, and then we go over here. We have 25. Well, let's find the LCD while we're at it so it's not that complicated. 25 over 2 minus 25 over 2. It's just 25 over 2, but let me show you the steps. So this is just 50 over 2 minus 25 over 2 minus, this becomes 30 over 2. Now this is another place where we want to be careful. Minus times minus is plus 9 over 2. Okay? So remember, all this is useless, but I'm just trying to show you the final result. Alright, so you have 1 over 5 squiggly bracket. Let's see what happens here. Well, I think we can do this. 2/3 times, if you take the square root of 4 is 2 and then raise it to the 3rd power, that's 8. So square root of, okay, minus, here we have square root of 1 is 1, to the 3rd power is 1, 2/3. Bam. Close that, plus, over here, we have 50 minus 25. Or we can just say 50 plus 9 is 59. 25 plus 30 is what? 55. So 59 minus 55 is 4. So all this just simplifies to 4 over 2. Alright, I'm going to leave this as a fraction because we might have to deal with a fraction here. Okay, so now we have 1 over 5 times, so put this over 1, that's 16 over 3. So we have 16 over 3 minus 2 over 3 plus 4 over 2. So that's 1 over 5 times 16 minus 2 is 14 over 3 plus 4 over 2. All right, so find the LCD. You have 1 over 5 times double this, 28 over 6. And then you triple 4 over 2 because the LCD of 3 and 2 is 6. Triple that, you get 12 over 6. And then you have 1 over 5 times 28 plus 12 is 40 over 6. And then you multiply across. You have multiply 1 times 40, 40 over 30. Cancel out the zeros, 4/3. You see how much work is involved? There's so much room for error here. That's why the recommendation is, as soon as you're completely done executing your calculus step, you have it in this part, box this answer, and stop right there. Don't waste your time trying to lose your calculus points over demonstrating your arithmetic skills. That makes no sense. If you stop right here, you get your full credit. Or if you want to take the risk and waste your time and you get this, you get full credit also. Okay? Alright, so let's go over how this problem is graded. You get a total of 4 points in this problem. The first point comes by recognizing the fact that this is a composite integral. It involves multiple functions over different intervals. So if you set it up like this, okay, with your limits of integration correct, you get 1 point. Alright, the next point has to do with your ability to find the antiderivative. If you find the antiderivative correctly, so where is that? Right here. See this part right here? If you find the antiderivative correctly, you get 1 point for the radical function, and then you get another point for accurately anti-differentiating the linear function. Bam. And then your final answer comes from accurately applying FTC part 1. If you're smart, you stop right here, you get your 1 point. If you have energy and time to waste, or you're really good with your arithmetic, you compute, you still get 1 point here after doing all this work. Okay? So that's that. Alright, let's take a look at question 6c. It reads, suppose the function g is defined by g of x equals k root x plus 1 for 0 less than x less than 3, and then x plus 2 for 3 less than x less than or equal to 5, where k and m are constants. If g is differentiable at x equals 3, what are the values of k and m? Okay, so one thing you want to note is that if a function is differentiable, that automatically means that it is continuous. Alright, so let's write that down. Something to note. For short, you can just say differentiability implies continuity, but not the reverse. Okay, so you gotta be careful. Continuity. So if a function is differentiable, it's automatically continuous. Okay, so what's the rule that we're going to be using here for a function that's differentiable and continuous? Well, there are two conditions that must be met. So let's take a look at the rule. If a function is continuous and differentiable at, let's say, a particular value a, then we have the following conditions. The left-hand limit is going to be equal to the value of the function, and is also going to be equal to the right-hand limit. I'm going to skip value of functions here, but you can, in some problems applicable, but continuity left hand limit is always going to be equal to the right hand limit, okay? And also is equal to the value of the function. Condition number 2, the left hand derivative, basically you differentiate the function and find the left hand limit of your result, has to also be equal to the right hand derivative. Remember, all derivatives are limits, okay? So this should make sense to you. Alright, so this is the rule that we're going to be using to set up a system of equations which will solve to find K and M. Okay? Alright, let's start with condition number 1. Condition number 1, since G since G is continuous, what do we know? The left hand limit is going to be equal to the right hand limit. Alright, so just to refresh your, well actually this is a different function. Let's put it on a number line again, okay? So, okay, so from 0 to 3, from 0 all the way to 3, we have the radical function. So from there to there, we have k root x plus 1. We have a different set of equations here for this third part. Okay, and then from 3 to 5, we have a linear function. So from here to here, we have a linear function. Okay, all right, let's go ahead and draw that. So from here to here, oh snap. All right, so we have the linear function, which is mx plus 2. Okay, so let's just see what equation we can generate based on the fact that this function is continuous. Okay, so left hand limit is going to be the limit as x approaches 3 from the left of g of x, and that should be equal to the right hand limit, the limit as x approaches 3 from the right of g of x. Okay? Alright, so what function is active to the left of 3? K rad x plus 1. Okay, so it's going to be the limit as x approaches 3 from the left of k root x plus 1. That should be equal to the limit as x approaches 3 from the right. We have the linear function mx plus 2. Alright? Now, on the left side, plug in 3. We're going to evaluate this limit by direct substitution. So you have k root 3 plus 1. Nothing funny happening here. Just plug it in. And then here we can do the same thing. Evaluate this limit by direct substitution. Plug in 3 for x, m times 3 plus 2. Okay, and then we now have k root 4 equals 3m plus 2. Root 4 is 2, so 2k is equal to 3m plus 2. Ladies and gentlemen, we're going to call this equation number 1. Okay, this is the first equation that we're going to be using to solve for K and M. We're going to be having a system of equations, okay? The continuity condition will help us generate the first equation, and then the differentiability condition will help us to generate the second equation for our system, okay? Alright, so let's go ahead and do that part. So we have condition number 2, since g is differentiable at x equals 3, guess what? The left hand derivative has to be equal to the right hand derivative, or else the function is not differentiable at that point. Alright? So how do we find this out? All you simply do is you take the limit as x approaches 3 from the left of the derivative of the function, and that has to be equal to the limit as x approaches 3 from the right of the derivative of the function. Okay. All right. So let's go ahead and substitute the function in here. So we're gonna have the limit as x approaches 3 from the left of the function active to the left of 3 is the radical function. Okay. So k root x plus 1 prime, okay, equals the limit as x approaches 3 from the right of g of x is the linear function mx plus 2, so we're going to be looking for the derivative of that also. Alright, so let's do it. Now I'm going to differentiate this one right here. Now I'm going to use a shortcut, okay? So remember, the derivative of root x is 1 over 2 root x, okay? If you're looking at the derivative of root u, you're going to use the chain rule, right? So it's going to be 1 over 2 root u du dx. du dx. We're going to be using the chain rule here, but what will happen is that we have a linear function, so the derivative of the inner would just be the slope. In this case, it will be 1. Okay? Alright, so let's go ahead and differentiate first before we take the limit. So leave that alone. The derivative of that is going to be 1 over root u. U in this case is x plus 1, okay? So it's going to be k over root, oh, there's a 2, I'm sorry. K over 2 root x plus 1, 2 rad x plus 1 times the derivative of x plus 1, which is just 1. Okay, now this is the deal. When you're integrating and the inner function is linear, you divide by the coefficient. Okay, when you're differentiating, you multiply by the coefficient of the linear inner function. That's just a shortcut to help you out. Okay, so we have that on the right side. This is much easier to differentiate. You have the limit as x approaches 3 from the right. Derivative of mx is just m. Derivative of 2 is 0. Okay? Alright, now we can evaluate the limit. So we're now going to plug in 3 into the x's if it has an x. So we're going to have on the left side k over 2 root. Instead of x, we put 3 plus 1. Okay? On the right side, this is independent of what x is, so it just stays m. Bam. Alright. Let's see. Oh, we can make this look pretty. So we're going to have k over 2 root 4 is equal to m. And then simplify a little bit further. Square root of 4 is 2. So you have k over 2 times 2, which is 4, equals m. Ladies and gentlemen, we have equation number 2. Okay, so now we can set up a system of equations that we can use our algebra skills to solve for m and k. Okay, so we have the system. We now have the system 2k equals 3m plus 2. This is equation number 1. And then the second one is k over 4 equals m. This is equation number 2. Okay? So how do we solve this? Elimination or substitution? You can use whichever one. I want to use substitution because m is solved explicitly for in equation 2. So I'm going to substitute k over 4 for m in equation 1. If we carry out that substitution, we're going to have, what are we going to have? Let's see, k over 4 plus m. You have 2k equals 3 times k over 4. Let me color code it so you can zero in on where the substitution is happening. Plus 2. Okay? Alright, let's simplify this. We're going to have 2k equals 3k over 4 plus 2. So just subtract 3k over 4 from both sides. Alright, let's see, what does that give us? We have 2k over 1 minus 3k over 4 equals positive 2. Okay, so this one, if you double it top and bottom, you have 4k over 4 minus 3k over 4. So that will give you 5k. Well, actually, it's not 5. It's 4 minus 3 is 1. Okay, so it's going to be, let's see, I'll actually multiply this by 4. Multiply by 4. Oh, yeah, so you have 8k minus 3, so that's 5k over 4 equals 2. All right, and then to get k isolated, you multiply both sides by 4 over 5. Just multiply the entire equation by 4 over 5. Okay, so when you do that, that gives you your first answer. K is equal to 2 times 4, 8 over 5. Bam. So that's one of the answers. Now for the second one, we're just going to plug in this result into equation 2 because it's already solved explicitly for m. Alright, so from 2, we have k over 4 is equal to m. So we're going to just plug in that. So 8 over 5 over 4 is equal to m. So put this over 1, you multiply the numerator by the reciprocal of the denominator, like that. And then what does that give us? 4 goes here 1, 4 goes here 2. That implies that m is 2 over 5. Alright, so let's write our answers. K is equal to 8 over 5. And m is equal to 2 over 5. That's the values of k and m that we're looking for in this problem. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your preparation for the AP Calc exam, give us a thumbs up. Your positive feedback is very helpful and supportive to us. If you have any questions about anything we covered in this presentation, just place your questions in the comment section below, and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other great tutorials such as this. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day. Goodbye.